I'm going to show you how to fix this turbo drain permanently. So this one, it says arz.com on it. It's flared to kind of help with the drainage, but it still has a problem. The main issue is this guy has this on a really big turbo that requires a lot of oil, and it's just not able to flow properly. It measures 12.59 millimeter on the inside there, and I'm going to cut it out to 0.625 is what I'm going to cut this out to, and I'll show you the process of doing that. And this will fix the issue with this turbo blowing oil. A lot of people with new turbos, they put these on there, they leak oil, buy a new turbo, another new turbo, still leaks oil, have it rebuilt, still leaks oil, then they just get confused and says everybody sucks at rebuilding turbos. So let's get down to it and I'll show you how to fix this. When I start this out, I want to find out my 0 point. So I'm going to do Y first. Down here I got 0.4285, up there I got 0.7230, and then we'll go to 35. That's 35 and it threw it out, so we're going to go with 7230 on that. So do here to figure out the center is we're going to add both of these together. Make sure you pay attention to if they're positives or negatives. Both of these are positives, so if they are positive and negatives, you just keep the sign with it. So we add these two together and divide by 2. I took the two numbers, added them together, got 1.1515. I divided that by 2. This is in order to find the delta, which is the center of these two numbers. So the delta is 0.57575. You need to round that to 0.5755 or 0.5760. I'm at 0.5760. To zero that out, we're going to press Y and set. And also, it's good to know that if you wanted to put this as set this as any coordinate you want to, press Y. You can put 2.3, whatever. That's now 2.3, but we need this location to be 0. So don't forget your negatives. So this negative number plus this negative number equals this negative number, which is correct with the machine. Divide that by 2 equals this number and a negative, and we'll have to round that up. So this number is where we need to travel the machine to in order to put it in center. So we're going to go to negative 2.54, you go to 85, or you can go to 90. So we'll do 85. And just zero that out. So also keep in mind, you can only zero these out in the digital readout mode and not in the jog mode. If you press these buttons when it's in jog mode, it moves the tool table. And it would move the Z-axis if my 3-axis part was working, but it doesn't. What we're going to do to write this program is we'll go to back. Now if you're not sure where you're going, just always press the back button. First we'll go to setup and tool table, and we'll tell it that we're going to have a 1/2 inch mill, so we're going to go up 0.5, enter. Doesn't really matter what you put for here. If you want to change it to something to keep it long term, you can. We're doing a simple thing. This is all going to get erased later, so we really don't care. So keep that in mind. Tool number 1 is what we're using with the 1/2 inch end mill. So when we write the program, we need to put tool number 1 as our selection. Go to program. Oh, you saw I pressed back earlier. Go to program. Go to beginning. This is another program that's already in here for the T51R mod. I need to delete all this stuff. Now that there's nothing in here, we'll go to profile, circular, 0, 0 is our reference point. because that's the center of the part. And it's asking for the radius. We want the diameter to be 0.625. So we'll divide that by 2, which would be 0.3. What is 25 divided by 2? 2 divided by 2, 1. 5 divided by 2, 25. 3.125. Direction, clockwise, number 2. Tool offset. We're cutting an inside cut. So if we're cutting inside of a circle and we want to be left of that radius or diameter, we'll choose left, which would be an inside cut. If we're cutting a groove in the center, we would choose center. So the groove would basically be divided, or in the center of this diameter, so half of it will be on one side and half will be on the other side. And then if we're cutting an outside cut, we would choose right. So you have the circle, you'd be cutting on the right of the circle, which is going to leave material in the middle. So we're going to cut on the left. 2. Finishing cut. We don't have to put anything for that if we don't want to, but if you want it to have a better finish or a really nice finish, and you feel like you need it, you could add, or you could select how many thousandths you want to leave after your rough cut before it does a finishing cut. So the finishing cut, if you put 10 thousandths there, it'll cut it 10 thousandths smaller than basically, I guess, the diameter, or maybe it's the radius, I don't know, not sure. It would cut it 10 thousandths smaller, and then the final pass would be a 10 thousandths pass. Feed rate, I'm going to put 10. We can always change that up or down. Tool number 1, you can just press set and it will automatically choose tool number 1. So that's our program. If we're confident in our program, we can test it over here. If we're super confident, and then we can just go ahead and duplicate it. So I'll go here and duplicate it. Repeat. First event was 1, last event was 1. These are presets, so like you can just go ahead and enter it if you're doing a simple program, and you know it basically allows you to move very quickly on the program. So it's saying the offset in relationship to the last offset, it's going to be an incremental value, because if you're trying to machine multiple parts on this machine, it's going to be incremental in relationship to the first 0 position. So we'll hit the incremental set. The absolute set button does not work to enter that in. Repeats, I'll do 10. Feed percent, 100% of the feed of last time's program. Tool number 1. Is that easy? Okay, now mode, run. Let's look at if we're going to crash. Nope. Start. It gives you instructions. Ready to begin when go. Now it's saying load the tool, enter this tool here, which basically if you have a bunch of tools already set up on the machine, you can label them tool number 1, 2, 3, whatever in your tool cart, and you can just grab them. For the most part, I just do a lot of simple jobs, so I'm not that advanced into doing that and saving all that information and all that stuff. So right now it's telling me to turn the spindle on, so we would turn it to the number 2 position, but before we do that, see it's already in low speed, we need to change it to high speed, so we're going to kick that over. If it's not moving, you need to jiggle the spindle here, and it just snaps right into place. Now we're going to be reading off our high speed. If we turn it to number 2 in high speed, it's going to turn in the direction that we need. If we turn it to number 1, it'll turn the wrong way, so we have to pay attention to what we're doing. Number 2, we can set our speed if we feel like it needs to go higher than that or lower. Let's go ahead and bring it down and try to simulate a program. I'm getting ready to run this program. keep in mind I'm not in the part right now for a reason. I'm not in the part because it's only asking me to load the tool, and it's going to wrap it over into position. So as soon as I hit this go button, it's going to wrap it over into position. So watch it. I just moved. It now is giving me instructions to set my Z point. So I'm going to move the tool into the part and make my first cut. It's a wise idea to set your Z there at the top of the part so you know how much you're cutting per pass into the material. So I'll press go for a simulation. Okay, it just ran it, so I'm going to run it for real this time. So I set my Z at the top of the part. I want to cut basically about 100 thousandths off this pass. I'm ready to run the program. I turned my override down, so it's at a feed rate of 5. I can turn that up later. Just trying to be safe. These are your override keys for your feed. I can turn that up or turn it down. Okay, so it's ready to run. I'm going to press the go button here and watch it run. At the end of the first program, it says to check Z. The reason it's saying that is it's basically, if you're not cutting in that position, you're cutting a second part. It's expecting that you're going to lift the tool out of the part so that you can press go again for it to wrap it over to the second part. But I'm cutting in the same position, the same part, multiple times, and this is the only thing I'm doing. So I just went ahead and put Z deeper, another 100 thousandths, and I'm going to press go and run this program. So let's just keep running it until we're all the way to the bottom. That looks amazing. Just look at it. It looks great. Okay, so you notice there's a little edge on the top. I'm going to show you how to fix that. It's a little thin. So we're going to go back to our program, make some edits, and we'll just run a program, same program, but we'll change it to cut in the center rather than the inside, which the inside is left, outside is right, center is right there in the middle, right across the top. We'll just trim all that off. So we're in our program. So like if you, well, the first thing I would do is go to your second event, erase all the events from that point forward. We're going to go back to the first event, and so go back. We want to go down here to the tool offset and change that to center. So we'll press data forward. Now if you were basically trying to go down here by pressing this stuff, you know, enter, it sticks right there every time. So it wants you to re-enter that. To avoid that, just go to data forward, and then we're going to change that offset to center, which is 0. Boom, done. And we don't need any of this, we don't need to change anything else. So this is our new program. Are we going to crash it? Maybe. Let's check it out. Mode, run. Start. Asking us to load the tool up and turn the spindle on. I'll turn the spindle on in a second. I'll just go ahead and press go since it's kind of hard for me to hold everything in one hand. So we'll turn the spindle on. Let me just set this without the camera on, without me holding the camera. So I'll turn that on, and I'm going to bring the tool down here to make a cut and just go across it. Press this go button at the top. Okay, it's done. And we can turn the spindle off up here. We can release the tool. And now we have a really nice flat edge. And we can just kind of file that. And then deburr it on the inside. That'll be perfect. And if you're worried about how much you cut on the inside, you could measure that again. I feel pretty confident because, you know, I set all the measurements that I wanted it to be. As long as what I entered in the machine was correct, which is the size of my tool, 1/2 inch, 0.3125, multiply that times 2, and that's 0.625 for diameter. If not, it's pretty close, so that'll work. I'm ready to take it out. And also to make that straight, I use these parallels. So that's what it looks like. Go ahead and trim it with my trim tool and be done with it. But this will fix the blowing oil problem. Here's how you finish this thing up. I got this little trim tool. It works really good for inside cuts. You can try it on outside cuts. I think it just works a lot better on inside cuts. And that's really all you need to do to it, to cut that out. It puts a little chamfer on it. And then the outside, I'll just file that a little bit, and it'll be good to go. So here is our measurements. See how accurate that was. Quite incredible. Let's take a look at it. Very smooth cut.